17 complex numbers problem. Question. First one, we compare the quadratic formula to what we're given. You can see that a must equal 1, b equals 2, and solve for b squared minus 4ac equals 19, and you get negative 3.75. Now that's not an integer, so multiply everything by 4 to get your answer as 4x squared plus 8x minus 15. Second question, put u and v on the diagram. We want u times v, so multiply those together, expand it out, and your answer is negative 5i, which you draw on the grid for your second achieved mark. For the next question, we have x squared plus 3x plus 2, so factorize that. That means that negative 2 and negative 1 are roots. Use synthetic division. We multiply diagonally in blue, putting the answer underneath, add going up. Go in green backwards, 0, so it must be 2 at the bottom and negative 1. And so there you use the top line for your next synthetic division, and you put the negative 1 as the root. Again, multiply, work backwards from 0, and we have the upward centre one is negative 4 minus 8 plus a equals negative 1, so a equals 11. And if a equals 11, you take the third column in the top diagram, top synthetic division, 16 minus 2a plus b equals negative 1, and you solve by substituting in a is 11, and you find that b is 5. So therefore you've found a and b. Check them, that they are correct. So by putting a as 11 and b as 5, you have found that it is correct. They both equal 0 when you put the solutions in. That's for merit. For this one, we only want the argument for wz, so multiply w and z together, expand, that gives you 17 plus 17i. I would then draw that on a diagram. You can see that the angle is the one you want. It's an isosceles triangle, right angle, so it must be 45 degrees or pi over 4 radians. For E, here is the answer for E, so you can go through that yourself. If you're an excellent student at excellence level, you should be able to follow that through. There's my way of doing it, and I found that it equals K. Next we'll go on to question 2. We want the modulus and argument. Put it on a diagram. It's a right angled triangle. The hypotenuse, used Pythagoras theory, square root of 2, and the argument is below the axis, so it's negative pi over 4 radians. For the next one, we have here squared terms, so square root both sides. So when you square root both sides, you find that 1 over z squared equals negative 2 plus or minus 2, so it's 0 or negative 4. Now 1 over z squared does not equal 0, does not work, and we find, excuse the email there, and we find that 1 over z squared minus 4, 1 over z squared equals minus 4, that's plus or minus 2, and complete it, and we find that z is negative 1 times plus or minus i, that's plus or minus i times a half. So there are your factors. You've solved the equation there. Those are the complex roots. For question C, these must come in conjugate pairs. So you've got 2 plus 3i, the other one is 2 minus 3i. So what we do is we put z minus 1 root, z minus another. Expand out your brackets. The green terms will cancel, as will the yellow terms. And then we just go ahead, simplify it down, and that gives you plus 9. You then get to the question, that what it's asking, so you've found that it is a factor. The next question, we want the roots there. We start with the formula a cubed minus b cubed. Will give you that particular answer. So apply that to z and k. When you've done that, use the quadratic formula for the second bracket. You'll find out what k is, work it through, and Then you have to note that your first bracket is also equal to 0, so z will equal k. There are your three roots. Add them all together, and we find they equal 0. That's nice and handy. The next question, E, we have to find two distinct solutions, and so there they are. There is your solution to that one there. And finally, question 3. Question 3, we multiply by the conjugate of the denominator to be able to get rid of the square root at the bottom. That will give you 1 at the bottom, and that falls out nicely into the form that we are asked for. For this one here, we asked for the argument of VW and V divided by W. For multiplication, you add your arguments, so add those fractions. For division, you subtract your arguments, so you subtract those fractions. 2 answers, achieve level. For this one, we've got the roots. These will come in conjugate pairs. When you're doing synthetic division, make sure you put 0 for the z squared term. There must be 5 terms there because you get the first one is z4, z3, z2, z1, and then the number by itself. Multiply diagonally, add going up. Take the top line for your next one. I remember to say, because the remainder is 0, you've found a root. Do the same for synthetic division there. And use the quadratic formula for your top line, which is 1z squared plus z minus 1. And you'll find that it comes to -1 plus or minus root 5 over 2. Whoops, and what happened there? So there are the 4 roots there. The next one, let A equal, let U equal A plus BI, and let V equal C plus DI. So find the conjugates by putting the negatives in there. We're going to work on the left-hand side of the equation, so substitute for U and V and their conjugates, gathering your real parts and your imaginary parts together, then expand it. We find that I squared is -1. It's a difference of 2 squares. That comes out nicely, and that is the modulus of the right-hand side. So that is proven. That is a merit question. And the next one, for this one here, the roots there, and I haven't put it in yet, bother. I thought I had. So we'll, oh yes, here it is. There it is. This is the answer. So excellent students can go ahead with that one. Right, I hope that has been helpful. Let me know how you go.